Let's go ahead and calculate the gradient of AB, right? So we say that the gradient of AB will be equals to y2 minus y1 divided by x2 minus x1. So we have to decide which point we take in as point 2 and which point we take in as point 1, right? So let's take point A as point 2. So we're gonna have 4 being x2 and then 2 being y2. And then here for B, we're gonna have x1 and y1. So if we substitute that, for y2 we have 2, and then for y1 we have minus 4. So that will just be plus 4. And then everything divided by x2. What is x2? x2 is 4, right? And then minus x1. X1 is 6, so we have minus 6. So we have 2 plus 4, which is 6, divided by minus 2, right? And then this should be equals to minus 3, right? That should be equals to minus 3. Now let's do 3.1.2. That is saying, let's calculate the size of this angle here, right? So if we want to calculate the size of that angle and we already have the gradient of AB, we can just say that tan of that angle will be equals to the gradient of AB, right? So that angle there will be equals to tan inverse of the gradient, which is minus 3, right? And if you put that in your calculator, you should get minus 71.557 degrees, right? If we get a negative angle, we always add 180, right? And then if you do that, that angle should be 108.43 degrees. And we're moving on to 3.1.3. 3.1.3 says, let's calculate the coordinates of D. We can say that T is the midpoint of CB, because CT is equals to TB, right? So we're going to use the midpoint theorem, so to say. So what are we saying? For T, using the midpoint theorem, we're going to have x2 plus x1 divided by 2, and then for the y coordinate we have y2 plus y1, everything divided by 2, right? Since we have let BB have x1 and y1 as the coordinates, let's let C have x2 and y2. So if we compute that, we're gonna have the coordinates of T being minus 2 plus 6 divided by 2, and then minus 3 minus 4, right? And then divided by 2. So here we're gonna have T having coordinates. So we have minus 2 plus 6 divided by 2, which will give us 2, right? And then minus 3 minus 4 divided by 2 should give us minus 7 divided by 2, right? And let's use 3.1.4. So 3.1.4 here is saying that let's determine the coordinates of S. Lucky we are given the equation of line AC, right? It's given to us here in the equation. We're given the equation for line AC. They're saying that equation, we have 5x minus 6y being equals to 8, right? So we can just so S, let's look at S. You can see that the x coordinate of S then is going to be 0, right? So we can just substitute that. If we substitute that, we're gonna get 5, 0 minus 6x is equals to 8. So that 5 is just gonna fall away, right? So you just have y being equals to 8 divided by minus 6, right? If we divide everything by 2 there, we should get 4 divided by minus 3. So the coordinates of S is 0 and minus 4 divided by 3. Now let's do 3.2. So 3.2 here is saying that let's determine the equation of CD in the form y is equals to mx plus c. So let's go ahead and look at CD. So we have a CD here. So here's CD, right? But then is said to us that CD is parallel to AB, right? So we already know that M is equals to minus 3, because don't forget that in 3.1.1, when we calculated the gradient of AB, we got minus 3. So now we just are looking for C here, right? Of which we're gonna do by substituting our point C, right? If we substitute C of coordinates minus 2 and minus 3, we shall get y is equals to in place of y we put in minus 3. We're gonna have minus 3 is equals to, and then the gradient is minus 3, right? So we have minus 3, and then x is minus 2 plus c. So we have minus 3 minus 6 being equals to c, right? So minus 9 is equals to c. So equation is now y is equals to minus 3x plus c. C is minus 9. So let me just see if that works real quick. So if we substitute minus 2 and then we minus 9, we're gonna get 6 minus 9, which is equals to minus 3. So it seems like we're on the right track here. Yeah, let's carry on and see what happens. So if we do, if we come to 3.3 here, and then 3.3.1 is saying that let's find the size of DCA. So DCA, let me just erase what we have here for a bit of clarity. So DCA is this angle here. This question is for 4 marks, right? I did spend some time thinking about this question. I don't want you to think that I just saw the question and then I jumped straight into the answer. I had to, think about a lot of things in order to answer this question that we have here. So these kind of questions, they demand a lot of thinking, right? And you should be willing to do that. But let me show you something. This size here, this angle here, A, right? This angle here should also be A, because DC is parallel to AB, right? So, and then apart from that, using CA, we can find this angle of inclination that is here, right? And then if we have that angle of inclination, we can say that this angle here is equals to DCA plus this angle here, right? An exterior angle of a triangle is equals to the sum of the two interior opposite, right? And then from there on, we can then find that angle DCA. So let me show you what I'm talking about. We're saying that angle DPO will be equals to this angle here. We calculated it. We say it is 108.43. So 108.43 degrees, right? And then we say that we need this angle because it will be equals to this angle here, and then we're gonna use exterior angle of a triangle, right? So let's calculate that angle. How are we gonna calculate it? We're gonna say that tan of theta is equals to the gradient, right? So here we're gonna say that theta is equals to tan arc of the gradient. So what are we saying? We're saying y2 minus y1 divided by x2 minus x1. But then just for the sake of time, we're just gonna do it without writing the formula down, right? So what is y2? Let's take A as our second point, right? So y2 should be 2 here, and then y1 should be minus 3, right? So that will be plus 3 because we say y2 minus y1. And then now let's look at x2 minus x1. So x1 is 4, and then x2 is minus 2, so that should be plus 2. So we're saying that theta is equals to tan inverse of 2 plus 3 divided by 6 essentially, right? And that should be equals to 39.81 degrees. So this angle, we can replace it with 31. We're replacing it with 31.81, right? So this angle here should also be equals to 39.81. I meant, yeah, what am I writing? I'm saying 39.81. Yeah, that's what the calculator says. 39.81. I don't know what I was writing there. So now we can say that angle DPO is equals to angle DCA plus angle angle what? Angle PFC, PFC, right? And then we're given the reason the exterior angle of a triangle is equals to two opposite interior, right? Yeah, the story goes on. So what is DPO? DPO, we know that it is 108.43, and that should be equals to DCA, which we are looking for, plus PCF, which is 39.81. So now DCA should be equals to, so we say in 108.43 minus 39.81. I'm getting 68.62 degrees. Doesn't look too bad, right? 68.62 degrees is believable. Let's do the last question. 3.32 area of POSC. So let's erase everything again and just look at POAC. So we have POSC, not AC, POSC. So let's look at POSC. Okay. I think thought of a way. So because let's do this. Because we have this angle here, right? We know the size of that angle. We can use the side CF and the side CP to calculate the size of that of triangle PCF, right? After we have calculated the size of triangle PCF, then we can subtract triangle OFS, right? We can subtract the triangle, and then we're gonna have the size of, or the area of POSC. So let's go ahead and do that. So we're saying that we're using CP and CF, right? So let's calculate CP. Here comes the distance formula. The formula I hate more than any other. So we need the coordinates of P, right? And then we have the equation of CD, right? We calculated it in 3.2. So on the equation of CD here, if we substitute, so we're letting y be equals to 0, right? So if y is equals to 0, let's just work it out here. If y is equals to 0, then 9 should be equals to minus 3x. So x should be equals to minus 3, right? So we're saying for P, we have minus 3 and 0. And then which other one do we need? We also need the coordinates of F, right? We have the y coordinate of F is 0, and we are given the equation of AC. So let's look at the equation of AC. The equation of AC is given as 5x minus 6y is equals to 8. So what is 5x? We say in y is 0, so we're gonna have 5x being equals to 8. So x is equals to 8 divided by 5. So here let's say 8 divided by 5. Yeah, so let's go ahead and calculate CP. So CP is going to be equals to, so distance formula, we say y2 minus y1 squared plus x2 minus x1 squared, right? So CP, let's let P be the second point. So if we say y2 minus y1, we're gonna get 0 plus 3 squared plus x2 and then plus 2 squared, right? So let me just compute that real quick and see what I get here. Square root of 10, right? So now let me do CF. CF is equals to so CF, let's take F as the second point. So we're gonna have y2 minus y1, so we have 0 plus 3 and then squared plus x2 minus x1, so we're gonna have 8 divided by 5 plus 2 squared, right? CF, I'm getting 4.68 69. let's say 6861. Let's not round off to 2 decimal places when we're not at the final answer, right? So now we can say that the area of triangle CPF is equals to a half side 1, side 2, and then sine of the angle of the two sides sandwich, right? So that will be angle DCA. So the area of CPF will be square root of 10 multiplied by 4.6861 multiplied by sine of that angle. We said that angle is equals to 68.62. 68.62, and that should be equals to 6.8995 units squared, right? So now we can calculate the area of triangle OCF and subtract it from the triangle PFC to find the area of OSCP. So what are we saying now? We're saying that the area of that triangle. So let's analyze that triangle. So we can easily find the length of OF, right? And we can easily find the length of OS, and then the angle they will send, which is this one, which is 90, right? So I think that's the best way to go. So we can say that OF is equals to 8 divided by 5, right? It's easy to see. And then OS is equals to do we have the coordinates of S? Yeah, 3.1.4. Let me look. So that will be 4 divided by 3, right? So OS is equals to 4 divided by 3. So I can say that the area of triangle OSF will be equals to a half multiplied by 8 divided by 5 multiplied by 4 divided by 3 multiplied by sine of 90, which is just 1, right? So we just have a half multiplied by 8 divided by 5 multiplied by 4 divided by 3, which is equals to 1.0667. So now we can say that the area of POSC should be equals to 6. This is units squared, should be equals to 6.8995 minus 1.0667, right? And that should be equals to 5.8333 units squared. Let me know what you think in the comments. Let's go ahead and calculate the coordinates of P. So we have 4.1, which is saying that let's calculate the coordinates of P. We can see fully well here that M is the midpoint of the line PN, right? So if we were looking for the x coordinate of M, we would say that XM is equals to x of n plus x of P divided by 2, right? That's what we would do. We would be applying the midpoint theorem, right? If we substitute the corresponding values now, we're gonna get 3 being equals to x of n, which is 7, plus x of P divided by 2. So if we cross multiply here, we're gonna get 6 being equals to 7 plus x of P. So minus 1 is equals to x of P, right? We can see that. Now let's find y of P, right? We're gonna exploit the coordinate M again. We're gonna say that y of M, if that's what we were looking for, we would say y of n plus y of P divided by 2, right? So if we substitute again, we're getting minus 5 is equals to minus 2 plus y of P divided by 2. If we cross multiply this, we should get minus 10 being equals to minus 2 plus y of P. So minus 8 is equals to y of P. So the coordinates of P is minus 1 and minus 8, right? And minus 8. Let's do 4.2.1. So 4.2 and then we have 4.2.1. So 4.2.1 is saying that let's determine the equation of the cycle in the form x minus a plus y minus b squared is equals to r squared. So here we're going to use the coordinates of m again, right? 3 will be a, and 3 will be a, and y will be b, right? Or minus 5. So if we put that into this equation, we shall get x minus 3, we have squared here, right? Squared plus y minus 5, so that will just be plus 5, right? Squared is equals to r squared, right? Now we have to find r squared. So to find r squared, we're just gonna take a point on the circumference of the circle and substitute into this equation, right? Or we can just determine the length of mn using the distance formula, but then let's just substitute it into the equation. So if we sub in n of coordinate 7 and minus 2, we're gonna get so what are we getting? 7 minus 3 squared plus y is minus 2, so we're gonna get minus 2 plus 5 squared being equals to r squared, right? So there we just have 4 squared plus what? I think that's supposed to be 3 plus 3 squared, so we have 25 being equals to r squared. So now our equation will be x minus 3 squared plus minus 3 squared plus y plus 5 squared being equals to 25, right? 4.2.2. So 4.2.2 is saying let's determine the equation of KL in the form y is equals to mx plus c. So let's look at KL. Is this line here, which is a tangent to the cycle, right? So we don't have the coordinates of k, we don't have the coordinates of l, but if we calculate the gradient of mn, then we're gonna use that to find the gradient of KL, right? Let me show you what I'm talking about. So we're gonna say that the gradient of mn multiplied by the gradient of KL should be equals to minus 1, right? Because the radius is perpendicular to the tangent, right? So if we make the gradient of KL the subject of the formula here, we're gonna get minus 1 divided by the gradient of mn, right? So the gradient of KL will be equals to minus 1 divided by y2 minus y1 divided by x2 minus x2 minus x1, right? Obviously you can do this separately. You calculate the gradient of mn separately, right? But then I'm just gonna put it all in at once and yeah, see what happens. So doing that, minus 1 divided by y2, so let's take n as the second coordinate, right? So that will be minus 2 minus 5, so that will be plus 5, and then divided by x2, so we have 7 minus 3, right? And then now let me just put that in my calculator real quick and see what I get. So I have 3 basically, and then divided by 4, right? So yeah, the gradient of KL is minus 4 divided by 3, right? So now we can say that y is equals to minus 4 divided by 3x plus c. Now we can sub in n, right, in order to find c. So if we sub in n, we're gonna get minus 2 being equals to minus 4 divided by 3 multiplied by 7 plus c, right? So c should be equals to minus 2 plus 4 divided by 3 multiplied by 7, and this should be equals to, so we have minus 2 plus 4 divided by 3 multiplied by 7, so c is 22 divided by 3, right? So y is equals to minus 4 divided by 3x plus 22 divided by 3. But then this equation looks shady, so let me just substitute the x value of n and see if I will get the y value, right? Perfect. I'm getting minus 2 when I substitute 7. So I think we're good to go. And then the follow-up question 4.3. So 4.3 is saying that for which values of k will y is equals to minus 4 divided by 3 x plus k be a secant to the circle. So a tangent touches the circle once, right? And then a secant, it goes through the circle. So this line here would be a secant. It's going through a circle. This line here would be a secant. It's going through a circle, going through a circle, going through a circle, going through a circle. So as long as the line is going through the circle, then it's a secant, right? But then, yeah, don't think this question was easy at all. But yeah, let me propose something here. The gradient of this line KL is equals to minus 4 divided by 3, right? And the line we are also interested in has a gradient of minus 4 divided by 3, right? So let me show you something. If we shift k some units, right, and then it's somewhere here, right, it still has the same gradient, right? Then it will be a secant to our circle, right? And then we can even put it here. It will be secant to the circle. We can put it here. It will be secant to the circle. We can put it here. It still is a secant to the circle because it's going through the circle, right? But then the only problem arises when it is somewhere here, when it touches the circle only once at P, right? Then it will no longer be a secant anymore. So as long as the y-intercept, right, the y-intercept is between the y-intercept of KL and the y-intercept when it touches the circle at P, then for those values of k, because k is the y-intercept, right, x is 0. So for those values of k, that equation will be a secant, right? So we need basically the upper limit and the lower limit, but we already have this value here, right? Because we know fully well that that value is from the line KL, right? And then that value is 22 divided by 3. So we already know what k should not be greater than. Now we only need what k shouldn't be less than, right? And in order to do that, we're going to substitute the values of p, right? So we're gonna say that y is equals to minus 4 divided by 3x plus k, obviously, right? And then we subbing in p, right? We know the coordinates of p, minus 1 and minus 8 from the above equations. So if we substitute p here, we're gonna get minus 8 being equals to minus 4 divided by 3, and then in place of x we have minus 1 plus k, right? So k will just be equals to minus 8 minus 4 divided by 3, basically, right? So k will be equals to minus 28 divided by 3. So when k is between 20 what, the y-intercept, 22 divided by 3 and minus 28 divided by 3, right? That line y is equals to minus 4 divided by 3x plus k is a secant to the cycle. Now let's do 4.4. So 4.4 is saying that we have points A of some coordinate T and T, and B that are not shown on the diagram, right? And then 4.4.1 is saying that so we are told that from point A another tangent is drawn to touch the circle with center M at B, right? And then 4.4.1 is saying that let's show that the length of the tangent AB is equals to T squared, 2T squared plus 4T plus 9, right? I would like to know how you guys solve this problem. So if you did solve it, please leave your solution on the comment section and I will pin the comment, right? But still, let's do 4.4.2, right? This is very similar to that question that was saying that let's find the minimum distance between f is equals to x squared and that coordinate, I think it was like 10 and 2. But then anyway, so let's solve the problem we have. The problem here is in that let's determine the minimum length of AB. So we know that AB is equals to 2t squared plus 4t plus 9, right? So because we have a square root here and I don't like square root, I don't like dealing with square roots, I'm going to square both sides, right? So that I can easily digest the problem. So I will have AB squared being equals to 2t squared plus 4t plus 9. Since we're looking for the minimum length, I can derivate this and equate to 0, right? Because let me show you something. This graph is going to be concave up, right? If it's concave up, then here at the turning point, we're going to have the minimum value, right? So we can derivate this and equate to 0 and then find the value of t of which we are going to have the minimum value, right? So if we do that, we're gonna get 2t squared if we derivating that. So we say in AB squared, we're finding the derivative of that. We're gonna get 4t plus 4 being equals to 0. So t here should be equals to minus 1. Let me show you something. Because we're basically looking for the x value of the turning point, right? We can also see that that x value t is equals to minus b divided by 2a, right? Because we just have a quadratic function. So this will be minus 4 divided by 2 multiplied by 2, which is equals to minus 1 again, right? So the distance, the length is at a minimum when t is equals to minus 1, right? But now let's substitute minus 1 into our equation and actually determine the minimum length, right? So the minimum length will be, so we have 2 multiplied by minus 1 squared plus 4 multiplied by minus 1 plus 9, right? So AB will be equals to so minus 1 squared, so we're just gonna get 2 and then minus 4 plus 9. So we have 2 minus 4, that should be minus 2, right? Plus 9. So we have the square root of 7 basically as the minimum length of AB. We're looking for the value of t, the y coordinate of point A, right? But it is easy to see that point A lies on the line AF, and we're given an equation for that line. So for 3.1.1, we can say that y is equals to minus x minus 11, right? And then now we can go ahead and substitute our coordinate A in the equation, right? If we do that, in place of y, we're gonna put t, and then in place of x, we're gonna put minus 1 and then minus 11. So t is a constant. So minus multiplied by minus 1 will give you plus 1, right? And then minus 11. So now it's easy to see that t is equals to minus 10, right? So just like that, we have our 2 marks for 3.1.1. Let's go ahead and do 3.1.2. So we're looking for the size of this angle alpha that is right here, right? That is our angle of inclination. And we know that to find an angle of inclination, we can easily say that tan of theta is equals to the gradient. So we have tan of alpha being equals to the gradient of that line. Is the line AF, right? And then the gradient is given here in our equation. We know that we have y. So let me just put m here. We know that we have y is equals to minus x minus 11. And then the general format or the general form of a straight line is y is equals to mx plus c. So it's easy to see that our gradient is minus 1, the coefficient of x. So we're going to have tan of alpha being equals to minus 1. So alpha is equals to tan inverse of minus 1. Right. So now it's just a matter of putting that in my calculator so that I can see what I get. So I'm getting minus 45. So our angle is minus 45, but we have to add 180 if it is negative, right? And then if you add 180, you're gonna get 135 degrees. So right, the size of that angle is 135 degrees. We're just using the fact that tan of theta is equal to the gradient of that line, right? And then moving to 3.1.3. So 3.1.3 is saying that let's calculate the gradient of AC. So we're looking for the gradient of AC to the nearest whole number. So here we're doing the opposite. We are given the angle and we are supposed to find the gradient, right? We're doing the same thing we did in 3.1.2, but then now the variables are just switched around. So we can say that tan of theta is equal to the gradient. Instead of finding the gradient, or instead of finding theta like we're doing in 3.1.2, here we're finding the gradient. So we're going to say that tan of our angle is 63.43 is equals to m. So let me just go ahead and say tan of 63.43 is giving me 2, right? So our gradient seems to be 2. So m is equals to 2. That is 3.1.3. Yeah, I think up to so far there hasn't been anything that is so complicated. Let's see what the following questions say. So 3.2, determine the equation of AC in the form y is equals to mx plus k. So AC is this line here. Like I've said, the general form is y is equals to mx plus some constant here. Let's let our constant be k, right? Because that's what the question is requiring of us. So we already have the gradient. We calculated it in 3.1.3, right? So we can go ahead and say that y is equals to 2x plus k. Now we just need to find the value of k. How do we do that? We substitute a point on that line. A is a point on the line AF and is a point on the line AC. So again here, we can substitute A. So A is minus 1 and T. But now we know what T is. T is minus 10. We've already calculated that. So we're going to have minus 10 being equals to 2 multiplied by minus 1 plus K. So minus 10 is equals to minus 2 plus k. It's easy to see that minus 8 is equals to k, right? So y is equals to 2x minus 8. Right, we can substitute the x value of a and see if we're going to get minus 10. If we substitute the value of the x value of a, we're going to get 2 multiplied by minus 1 minus 8. Minus 2 minus 8 is equals to minus 10. So it seems like we have the right equation because it works at that point. Right, so that is 3.3. Let's go ahead and do 3.3.1. So 3.3.1. We're looking for the coordinates of C. We're looking for the coordinates of C. Yeah, C is up here. We're looking for the coordinates of C. So let me just tell you something. The distance from A to B is equals to the distance from B to C. So B is the midpoint of the line AC, right? We know the y value of B is 0, right? Because it is an x-intercept. So what we can do is to find the x value of B using the equation we calculated in 3.2, right, of the line AC. So we can say that y is equals to 2x minus 8. We know that we have an equation for that line. It's y is equals to 2x minus 8. Yeah, I'm just trying to make that clear if anyone was a bit lost. So if we sub b, the x value is unknown and the y value is 0, right? So we're gonna have 0 being equals to 2x minus 8. So take 8 to the other side, you're gonna get 8 is equals to 2x. It's easy to see now that x is equals to 4. So b has coordinates 4 and 0, and it is the midpoint of AC, right? So in order for us to calculate the x value of c, we can say that x of b is equals to x of a plus x of c divided by 2. What is x of b? That's 4. X of a minus 1 plus x of c divided by 2. It's easy to see now that we're solving for x of c. If we cross multiply, we're gonna get 8 is equals to minus 1 plus x of c. So 9 is equals to x of c. We have x of c now. So again, we can use the midpoint. We can use this idea for the y values and find y of c, right? Or we can just substitute this coordinate into our equation. So let's use both and see if we get to the same place. So again, here let's say x of, not x but y, we want y now. Y of b is equals to y of a plus y of c divided by 2. So y of b, that is 0. Y of a is minus 10. Yeah, it's minus 10. Yeah, it is. And then plus y of c divided by 2. So if we cross multiply, 0 multiplied by 2, that is 0. So minus 10 plus y of c. So 10 is equals to y of c. So the coordinates of c, we have 9 for the x value and 10 for the y value. But let's substitute this coordinate into the equation for that line. So the equation of that line says 2x minus 8, right? So we're gonna have 2 multiplied by x, we're saying that is 9, and then minus 8. 2 multiplied by 9, that is 18, minus 8 is equals to 10. So yeah, we get y is equals to 10 using both of those two ways. Right, that's what that is 9 not 9 but 3.3.1. right. Getting fatigue. I must be getting a little bit tired. 3.3.2. Let's find the size of FED. So this entire angle FED, right? So we want FED. So what can we do here? So right, we can find this angle here, which is part of FED, right, by saying 180 minus angle alpha, right? So let's say that we're going to be able to compute that. We know we can, but yeah. Now let's look at this part. How can we find the size of that angle? That's, what we have to think about now. We are told that the line DE is parallel to the line AB. If those lines are parallel, then that angle should be equals to this angle right here. They are corresponding angles, right? So let's go back to that first angle. So we know that alpha is 135. If alpha is 135 and the sum of angles on a straight line is 180, then this angle here should be 45 degrees, right? And then the other angle, we have 63.43 right here. We have 63.43, and then because of vertical opposite angles, this angle right here should also be equals to 63.43. So now we can replace this angle and write 63.43. So now we're done. We can say that FED is equals to 45 plus 63.43. I'm getting 108.3 degrees, and that is FED. Let's move to the last question. G is a point such that EAGC in that order is a parallelogram. Determine the equation of a circle centered at G and passing through our point B. Write your answer in the form y minus a squared plus y minus b squared is equals to r squared. Right, I'm so much interested in how you guys solve this question, so please just let me know in the comments. Can we find the equation of line BD if we are given the equation of line AC? Yes, we can. The equation of line AC is given by minus 1 divided by 2x plus 2. AC is perpendicular BD. That should tell us that the gradient of AC multiplied by the gradient of BD is equals to minus 1. So the gradient of BD will be equals to minus 1 divided by the gradient of AC. From the equation, we know that the gradient of AC is minus 1 divided by 2. So we divide in minus 1 by minus 1 divided by 2. The gradient of BD will be equals to 2. So now we know that for BD, y is equals to mx plus c, but the gradient is 2. So we have 2x plus c. All we need to do is substitute a point on our line BD and find the value of c. Just like that, we're going to have the equation of BD. We are given the coordinates of B, so let's go ahead and substitute that into our equation. We're going to have minus 7 being equals to 2 multiplied by minus 2 plus c. Minus 3 is equals to c. So now we can say that the equation of BD, we have 2x minus 3. Let's move to the following question, 3.2. We are supposed to find the coordinates of E. E is the point where AC intersects BD. This is a very common type of question. You shouldn't be getting this wrong. What are we going to do in a case like this? We're going to equate the equation of BD and the equation of AC. If we do that, we're going to have 2x minus 3 being equals to minus a half divided by 2x plus 2. We're going to find the x value of E and substitute it into either the equation of AC or the equation of BD. So minus 1 divided by 2x, if we take that to the left-hand side, we're going to have 5 divided by 2x being equals to. Minus 3 to the right-hand side, we have 2 plus 3. So this is equals to 5. So x is equals to 5 multiplied by 2 divided by 5. X is equals to 2. So that is the x coordinate at E. Let's substitute 2 into 2x minus 3. If we do that, we're going to have y being equals to 2 multiplied by 2 minus 3. This is just equals to 1. So the coordinates of E, we have x being equals to 2 and y being equals to 1. That is 3.2. Let's do 3.3. If the ratio CE is to EA is equals to 1 is to 3, determine the coordinates of A. That is not too difficult. Let's see what we can do. So E is to C and A is to E. We have 1 is to 3. So let's play around with these numbers. The coordinates of E, we have 2 and 1. We want to find the coordinates of A. X of C is 4 and X of E is how much? It is 2.
what will be x of A? From x of C to x of E, we moved 2 units to the left. Our ratio is 1:3. If we move 2 units to the left, then from x of E to x of A, we need to move 2 units to the left multiplied by 3. So we have 2 minus 6, which is minus 4. So that is how we can find the x value of A. And then now let's do the same for the y values. The y value of C is 0. What is the y value of E? The y value of E is 1. And our ratio is still 1:3. Now we're looking for the y value at A. From y of C to y of E, we moved 1 unit upwards. So from y of E to y of A, we're going to move 1 multiplied by 3. So that is 1 plus 3, which is equals to 4. So this is the y coordinate of A. So the coordinates of A, we have minus 4 and positive 4. Our answer to 3.3. 3.4. Kite PQRS is obtained after the measurements of kite ABCD is enlarged by a scale factor 2. Calculate the area of kite PQRS. Right, let's calculate the area of kite ABCD first. And then we're going to multiply it by a factor of 2 to get the area of kite PQRS. So I'm going to erase all this. BC is equals to DC. That is a property of a kite. We don't have to think very hard about that. It's either you know it or you don't. And then AB is equals to AD. So what we can do, we can calculate the area of one triangle. After calculating the area of one triangle, we just multiply it by 2 to get the area of ABCD, because these two triangles ABC and ADC are equals to each other. The area of triangle ABC will be equals to half base. Our base is AC multiplied by our height, which is BE. We need to calculate the length of AC and the length of BE. What is the length of AC? AC will be equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. Let's take our point A as our second point. Let's not forget, here we have coordinates minus 4 and 4. So x2 will be minus 4 and x1 will be 4. So we're going to have minus 4 squared plus y2. y2 is going to be 4 and y1 is 0. AC is equals to 4 square root of 5. Now let's calculate BE. BE will be equals to the square root of, we're looking at BE. Let's take E as our second point. So the coordinates of E, we have 2 and 1. Let's not forget. So y2 is 1 minus y1, which is minus 7. So we have plus 7 squared. Plus x2. x2 is 2 minus x1 minus 2. So we have 2 plus 2 squared. If you put that in your calculator, you're going to get 4 square root of 5. So the area of our triangle ABC is equals to a half multiplied by 4 square root of 5, square root of 5, not square root of 2, multiplied by 4 square root of 5. So now it's just a matter of putting that in your calculator, and we are getting 40. So the area of our kite ABCD will be equals to 40 multiplied by 2, which is 80. And now the area of our kite PQRS will be equals to 80 multiplied by 4 and not 2. This is equals to 320 units squared.
The question starts off fairly weak with 3.1, just asking us to find the gradient of BC. So we are given all the coordinates of B, and we are also given the coordinates of C. So we're supposed to substitute directly, not trickery whatsoever. So the gradient of BC will be equals to y2 minus y1 divided by x2 minus x1. So let's take B as our second point. If we do that, the value of y2 will be 8 minus the value of y1, which is going to be 0, divided by the value of x2, which is 4, minus the value of x1, which is 5. So we have 8 divided by minus 1, which is equals to minus 8. So that is the gradient of BC. Let's move forward and look at 3.2. So what does the question say? If the distance between points A and B is equals to square root of 65, calculate the value of K. So let's put that in math. They say that the distance between A and B is equals to square root of 65. So let's have the distance formula. If we do that, we're gonna have y2 minus y1 squared plus x2 minus x1 squared being equals to square root of 65. So when we substitute the coordinates of A and B, the only unknown variable we're gonna have is K, and then that is how we are going to find it. Let's go ahead and do that. So if we take B as our second coordinate, y2 is going to be 8, and then y1 is going to be K. We square that plus x2, that is 4, minus x1, which is minus 3. So it will be 4 plus 3. We square that, and it is equals to square root of 65. Let's go ahead and solve what is inside the bracket. So we have 8 minus k squared. How do you solve that? What is 8 multiplied by 8? That is 64. And then you multiply 8 by minus k, it will give you minus 8k. You multiply that by 2, you're gonna get minus 16k. And then minus k multiplied by minus k, that is just plus k squared. And then 4 plus 3, that is 7. You square that, you get plus 49 being equals to square root of 65. So what can we do here? We can take square roots of both sides. If we do that, if we square both sides, we're gonna have 64 minus 16k plus k squared plus 49 being equals to 65. If we take 64 to the right hand side, we're gonna have 1, and then if we take that 1 back, then we're gonna have 49 minus 1, which is 48. So we have k squared minus 16k plus 48 being equals to 0. So let's go ahead and factorize. Which two numbers do we multiply and get 48? But when we add them, we get minus 16. That is minus 4 and minus 12. So that is to say that k minus 4 multiplied by k minus 12 is equals to 0. So it's either k is equals to 4 or k is equals to 12. Let's look at what makes sense between 4 and 12. B is clearly above A in terms of the y value. So if the y value of B is 8, then the y value of A should be less than 8. So this k is equals to 12 cannot be correct, meaning that the answer is k is equals to 4, the y value of A. Let's move to 3.3. 3.3, we are supposed to prove using analytical geometry methods that BP is perpendicular to AC. So what are we required to prove? We are required to prove that the gradient of BP multiplied by the gradient of AC will be equals to -1. That's what we mean when we say BP is perpendicular to AC. So let's go to our sketch and see how we can find our way. So where is BP? BP is right here, and then AC is right here. There we go. We have AC. So A, we have the coordinates of A. We have all the coordinates of A. And we have all the coordinates of C. So it's easy to calculate the gradient of AC, right? So we have that figured out. What about BP? We don't have the coordinates of P. P lies on BD, and we have the coordinates of D. So we can just use the coordinates of BD to find the gradient of BP. For the gradient of BP, we're going to say y of B minus y of D divided by x of B minus x of D multiplied by AC. So let's say y of A minus y of C divided by x of A minus x of C. Right. And then what is y of B? Y of B is 8 minus y of D, which is -4, divided by x of B, which is 4, minus x of D, which is -2. And then we multiply that by y of A. We know what the value of K is now. The value of K is 4 minus y of C, which is 0, divided by x of A -3 minus x of C, which is -5. So what is 8 minus -4? That is 12 divided by 6 multiplied by 4 divided by -8. So we have 2 multiplied by -1/2, and this is equals to -1. So there we go. Those two lines are perpendicular, as the product of the gradients is equals to -1. Let's move to 3.4. 3.4, we're supposed to calculate the coordinates of F if it is given that ACFD is a parallelogram. So let's go ahead and look at F. F is right here. So if it is a parallelogram, let's go ahead and connect those points. If it is a parallelogram, then A and C, D and not A and C, but C and F, and then D and F. Yeah, we have something like this as our parallelogram, right? So in order to find the coordinates of F, we can use the midpoint of DC, as it will be the midpoint of AF, but that is a painful exercise. Instead of doing that, we're gonna use translation. Let me show you how, if you're not familiar with the concepts. So let's look at the x value of A. The x value of A is -3, and the x value of D, it is -2, and then the x value of C is 5. What will be the x value of F, right? So the way the x value of A and D differ is the same way the x values of C and F are gonna differ if A, C, D, F is a parallelogram. So here we have -3 and -2. You can see that from A to D is +1. Here we have 5. So for the x value of F, we must have 5 plus 1, which is 6. So we have covered the x value of F. Let's look at the y values. The y value of A is 4. The y value of D is -4. So from 4 to -4, that is -8. What is the y value of C? The y value of C is 0. So the way the y value of A and D differ shall be the same way the y value of C and F differ. So that will be 0 minus 8 which is minus 8. So the coordinates of f is 6 and minus 8. Yeah, so you can do that instead of using the midpoint. All right, let's move to the following question. 3.5. So 3.5, calculate the size of EDO, correct to 1 decimal place. So let's go to our diagram and look for EDO. EDO is this angle right here. This is EDO. How can we possibly find EDO? Well, I can see fairly quick that I can find the value of this angle here. If I find the value of that angle, then that angle will be equals to this angle. I think they are called vertical opposite angles, and they're supposed to be equals to each other. So I can use that angle to find this angle. And then I can find this angle. And then that angle should be equals to our angle of interest plus this angle here. The exterior angle of a triangle is equal to the sum of the two opposite interior. So how can I find this first angle that I'm claiming I can find? I can use the gradient of BD. I can use the gradient of BD, which I already have, because tan theta is equal to m. And then how can I find this angle? I can use the gradient of AD to find that angle. So let's go ahead and compute that. We're gonna see that tan of that angle is equals to the gradient of BD. That angle will be equals to tan arc of BD. But we have the gradient of BD. We calculated it when we were trying to prove that AC is parallel to BP. And it was 2. So what is tan arc of 2? That will give you so yeah, that angle is covered. Let's find this exterior angle of our triangle. We're going to use the gradient of AD. So we're going to say that that angle, what is it? Is it alpha? Yeah, we're going to say that alpha is equals to tan arc of y2 minus y1 divided by x2 minus, what am I doing? I already have the gradient of that line, because this line is supposed to be parallel to this line because our shape is a rhombus, right? So we said that the gradient of this line is minus 8. So we're gonna go ahead and substitute that. So we have minus 8. This will give you minus 82.874875. If it is minus, you must always add 180. If you do that, you're gonna get 97.125. So now we can say that our exterior angle is equals to 64.63 plus EDO plus our angle EDO. But we know that alpha is 97.125. So let's take 63.63 to the left hand side. We're gonna get 97.125 minus 64.63 being equals to EDO. If you put that in your calculator, you should get 33.7 being equals to EDO. The last question, let's do the last question. We're supposed to calculate the area of ADC. We're supposed to calculate the area of ADC. Let me highlight ADC because I cannot even see it. It's just a mess. With A is right here, and then D is right here. With C is right here. Because our shape is a rhombus, we have a 90 degrees angle here, and then if that is the case, then we can take AC as our base and DP as our height. So we can say that the area of triangle ADC is equals to half AC multiplied by dp. So we have the coordinates of A and C, so we can easily find AC. We have the coordinates of D, but we can find the coordinates of P using the midpoint theorem. So we basically have dp. Now it's just a matter of putting that in your calculator and finding your final answer, which should be equals to 30 square units. Write the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared. We are given an equation. It is said to be x squared plus y squared minus 4x minus 2y minus 13 is equals to 0. Before we do anything fancy, let's just group their like terms. If we do that, we're going to have x squared minus 4x plus y squared minus 2y. Let's take the constant to the right hand side. If we do that, this is going to be equals to 13. The next step you probably want to take is to complete the square. What do we mean by that? So we have x minus 4 divided by 2 squared plus y minus 2 divided by 2 squared being equals to 13 plus minus 4 divided by 2 squared plus minus 2 divided by 2 squared. There we go. So we're going to have x minus 2 squared plus y minus 1 squared being equals to 18. So that is the equation of the circle. Let's do 4.2. Write down the coordinates of n and the length of nt. So n is our center of the circle and nt is the radius. So the coordinates of n from our equation, the x value is going to be 2 and the y value is going to be 1 at the center. So we're saying that the x value is 2 and the y value is 1. And then how can we find the length of nt? Like we've already deduced, nt is the radius, and on our equation we have radius squared. So we can go ahead and say that nt is equals to the square root of 18, because 18 is radius squared and nt is our radius, so nt shall be equals to the square root of 18. Let's move to 4.3. So in 4.3, determine the equation of the tangent qt in the form y is equals to mx plus c. So let's go ahead and do some analysis. We have qt right here as our tangent. In order to find the gradient of qt, because we need to find the gradient if we want the equation, we're going to have to find the coordinates of t. Well, we don't have to necessarily find the coordinates of t for the gradient, because we can just use the coordinates of n, which is 2 and 1, and the coordinates of p. But then in order to find c, we're gonna need a point that lies on the line qt. So let's just go ahead and find the coordinates of t, and then I'm gonna use the coordinates of t to find the gradient, and after finding the gradient we're gonna use the same coordinates of t to find c. So how are we gonna find the coordinates of t? TP is a diameter, so that tells us that n is the midpoint of PT. So we can use the midpoint theorem. We can say that x of n is equals to x of t plus x of p divided by 2. So x of n, that is 2, x of t, it's what we're interested in. X of p is 5 divided by 2. If we cross multiply, we get 4 is equals to x of t plus 5. So x of t is equals to minus 1. Now we just need y of t. Y of n is going to be equals to y of t plus y of p divided by 2. What is y of n? That is 1. And then y of t, what we're interested in, y of p is 4 divided by 2. We cross multiply, we get 2 is equals to y of t plus 4. So y of t is equals to 2 minus 4, which is minus 2. So the coordinates of t, we have minus 1 and minus 2. So we can go ahead and find the gradient of qt. The tangent is perpendicular to the radius. So if we find the gradient of the radius, then we can use that to find the gradient of the tangent. We're going to have the gradient of nt being equals to y of n minus y of t divided by x of n minus x of t. Y of n, that is 1, minus y of t, which is minus 2. We have it right here. And then everything divided by x of n, which is 2, minus x of t, which is minus 1. So we have 3 divided by 2 minus minus 1, that is 3. So the gradient of nt is 1. Right, so now we can say that the gradient of nt multiplied by the gradient of qt is equals to minus 1. So the gradient of qt is going to be equals to minus 1 divided by the gradient of nt, which is 1. So the gradient of qt is equals to minus 1. So now we know that for our equation of the straight line of the tangent, y is equals to minus x plus c. Now we just need to find c. We're gonna substitute t of coordinates minus 1 and minus 2. If we do that, we're gonna get minus 2 in place of y and minus 1 in place of x plus c. So minus 2 is equals to 1 plus c minus 3 is equals to c. So now we have y being equals to minus x minus 3. And now we have the equation of qt. Let's move ahead and do 4.4. So in 4.4, the circle with center S of coordinates a and b touches the circle with center n externally at t. qt is a tangent to both of these circles. If ns is equals to 3nt, determine the coordinates of s. Yeah, there's a lot going on there. So let's go ahead and have a sketch for that circle and then try make sense of the situation we have. So they touch at t, and then qt is also a tangent at that circle. Yeah, another key point is that they touch externally, because if the question says they just touch, then that is very unclear. But now if we know that they touch externally, we can do something about that. Well, let's just take that as our circle and try make something of it. So it has a center S of coordinates a and b. So the coordinates of t, we have minus 1 and minus 2. What other information do we have? We're given the fact that ns is equals to 3nt. So let's try denote that in our sketch. Where is ns? ns, so this is the center of the circle S. So ns is equals to 3nt. This circle is actually supposed to be bigger than how I made it look, but well, that is that. The best way to approach a question is to start with the information that is given. So obviously ns is equals to 3nt. That is the first thing I'll be thinking about. So ns using the distance formula. Right, let's go ahead and do that. So this is equals to 3nt. We have 2 and 1 as the coordinates of n. If we take s as our second point, we're going to have y2 being equals to b minus y1, which is equals to 1, the y value of n, and then plus x2, which is equals to a, minus x1, which is equals to 2, the x value of n. If we square both sides, we're going to have b minus 1 squared plus a minus 2 squared. We actually know the value of nt because nt is the radius of the circle we started with, and that is square root of 18. So here we essentially squaring 3 multiplied by square root of 18. If we square that, we shall get 162. So let's just put that there. We have 162. We know that NT is perpendicular to QT. And then we also know that QT is perpendicular to ST. So that tells us that the gradient of ST will also be equals to 1. We can actually say that y of t minus y of s divided by x of t minus x of s should be equals to 1. So what is y of t? That is minus 2. Y of s, that is b, divided by y of t, x of t minus 1 minus x of s, which is a, being equals to 1. So if we cross multiply, we're going to get minus 2 minus b is equals to minus 1 minus a. We can make 1 the subject of the formula here. Let's make b the subject of the formula. If we do that, we're going to get minus b being equals to minus 1 plus 2, that is 1, and then minus a. We divide both sides by minus, we get b is equals to a minus 1. We can call this our equation 1. And then what we want to do is to substitute this equation into this equation. So let's do that. Instead of having b, we're going to have a minus 1 and then minus 1 squared plus a minus 2 squared is equals to 162. So we're going to have a minus 2 squared plus a minus 2 squared being equals to 162. A minus 2 squared is equals to a squared minus 4a plus 4 plus a squared minus 4a plus 4. If we take 162 to the left hand side, we're going to get minus 162 is equals to 0. So we're going to get 2a squared minus 8a minus 154 is equals to 0. We can take 2 as a common factor and get a squared minus 4a minus 77 is equals to 0. So now it's just a matter of factorizing this. Which two numbers do we multiply and get minus 77? But when we add them, we get minus 4. That is minus 11 and positive 7. So a minus 11 multiplied by a plus 7 should be equals to 0. A is equals to 11 or a is equals to minus 7. So we need to pick a value that makes sense. You can see that s is on the third quadrant, so the y value must be negative. So a cannot be equals to 11. It is equals to minus 7. And now we have a. We can find b because b is equals to a minus 1. So that is minus 7 minus 1, which is minus 8. So the coordinates of s is actually minus 7 and minus 8. We're supposed to write down the coordinates of m, right? So we're given an equation for that circle. It is said to be x plus 6 squared plus y plus 3 squared is equals to 25. So let's go ahead and extract the coordinates of m, right? The x coordinate will be minus 6 and the y coordinate will be minus 3. So the coordinates of m, we have minus 6 and minus 3. So if it was x minus 6, the x coordinate will be positive 6. And then if it was y minus 3, then the y coordinate will be positive 3. But then here they're positive, and then on our center we shall have minus 6 and minus 3. Right, that's how it works when it comes to the coordinates of the center of a circle. Right, let's do the following equation. 4.2.1. They're saying that let's calculate the length of the radius of the smaller circle. So right, we have the radius of the smaller circle. It is nt, right? We don't have the coordinates of t, so we cannot use the distance formula, but we are given the equation of the small circle, right? It is said to be, here it is, right here, right? We have x squared plus y squared plus 24x minus 10y plus 153 is equals to 0. Right, so we can write this as x squared plus 24x and then plus y squared minus 10y is equals to minus 153. Right, we just took plus 153 to the right hand side. So what you want to do here, you want to say x plus 24 divided by 2, 24 being the coefficient of x, right? And then we can square that. So you square that, and then we're gonna have plus y, and then we have minus 10 divided by 2, right? This coefficient of y, and then we're supposed to square that, and all of that will be equals to minus 153, right? But then you have to go to the right hand side and then say plus 24 divided by 2 squared plus minus 10 divided by 2 squared, right? If you do that, then you're gonna find the equation of your cycle. So if we compute that, we're gonna get x plus 12 squared plus y minus 5 squared is equals to 16, right? We're looking for the radius, right? So this 16 should be r squared. So we can say that r squared is equals to 16. So r is equals to 4. Right, that's relatively easy to see. Let's move to the following question, 4.2.2. We're looking for the length of TS. So 4.2.2, we're looking for the length of TS. Let's do some analysis so that we can see what is happening. TS is this distance here between the two circles, right? What we have is the radius of the smaller circle and the radius of the bigger circle, right? So what we can do, we can find the length of NM. We can find the length of NM. If we find the length of NM, then we're going to subtract the radius of the smaller circle and the radius of the bigger circle to find TS. So let's go ahead and do that. So we can see that MN is equals to, we're about to use the distance formula now. So we're going to have the square root of y2 minus y1 squared plus x2 minus x1 squared, right? So the coordinates of M, we have minus 6 and minus 3. And then the coordinates of N, we have minus 12 and 5, right? So to avoid any confusion, I'm going to say that this is x1 and this is y1, this is x2, this is y2, right? Obviously, you can do it in your head if you're comfortable with that, but yeah, I prefer just playing it safe. And then we're going to have y2 minus y1, so that will be 5 minus 3, right? So that will be plus 3. And then squared plus x2, that is minus 12, and then minus 6, so that will be plus 6. And then I square that. So now we have the square root of, so we're going to have 5 plus 3, 8 squared, that's 64. And then minus 12 plus 6, that is minus 6 squared, that is 36. So now we have the square root of 100, which is equals to 10. Right. So now to find TS, we're going to say 10 minus the radius of the smaller circle minus the radius of the bigger circle. The radius of the smaller circle is 4. The radius of the bigger circle is 5. So the length of TS is 1 unit. That is the length of TS. Right. Let's move to 4.3. 4.3 is saying that let's determine the equation of the tangent PR. So we're looking for the equation of the tangent PR. So let's go ahead and look at PR. PR is this tangent right here. PR is this tangent right here. Yeah, we are told in our equation statement that PR is parallel to the x-axis. PR is parallel to the x-axis. So our gradient is 0 on PR, right? So we just need to find the y value. Then y will just be equals to that constant. Right, so let me show you how we're going to do that. We know that the y coordinate of our center M is minus 3, right? Our point R and our center M, they share the same x coordinate, right? That will be true if indeed PR is parallel to the x-axis. So right, to find the y value of R, we're just gonna say minus 3 minus 5, the radius of our bigger circle, right? So if we say minus 3 minus 5, we're gonna end up with minus 8. So the y coordinate of R is minus 8, right? So now we're gonna have y is equals to minus 8, and that's all we have. That is the equation of our tangent PR. Right, now moving forward, I think you can also take this x value and substitute it in the equation for that circle. You would get y is equals to minus 8, and then have your tangent PR being equals to minus 8. But then the really interesting question here is actually 4.3.2. So 4.3.2, we need to find the equation of the tangent PS in the form y is equals to mx plus c. So let's go and do some analysis. Let me just get rid of all this junk so that we can have a bit of clarity. So PS is a tangent at S, right? If PS is a tangent at S, then MS and PS should be perpendicular to each other. Yeah, tangent perpendicular to radius, right? We know that is a theorem we have. So if PS is perpendicular to MS, then we can find the gradient of MS and then find the gradient of PS through that. So how can you find the gradient of MS? MS, we can find the gradient of that line using the coordinate M and N, right? Because S lies on the line MN. So we can just use those two coordinates to find the gradient of MS. So we can say that the gradient of MS, is equals to the gradient of MN. So we're gonna have y2 minus y1 divided by x2 minus x1. Right, so the coordinates of M, we have minus 6 and minus 3. Let's not forget. And then let's take M as our second point. Then the y coordinate would be minus 3. And then the y coordinate of N, that is 5, right? So we're going to have minus 5. And then divided by x2. So x2, we're going to have minus 6 minus 12. So that will be plus 12, right? So this will be equals to, on the numerator we have minus 8 and we're dividing by 6. It's easy to see that the gradient of Mn, the gradient of Ms will be minus 4 divided by 3, right? So now, because those two lines are perpendicular to each other, we can say that the gradient of Mn multiplied by the gradient of PS, the gradient of PS is equals to minus 1. Yeah, that is true. That holds if the two lines are perpendicular, right? So the gradient of the gradient of PS will be equals to minus 1 divided by minus 4 divided by 3, right? If you compute that, you will get 3 divided by 4, right? So we're saying that now the equation of PS is 3 divided by 4 x plus c. So we just need to find the value of c, right? We can do that by substituting the point k, which lies on the line PS. K has coordinates minus 17 and minus 5. So we're gonna have minus 5 for the y value, being equals to 3 divided by 4. The x value is minus 17 plus c, right? So now you can see that we just left with doing a bit of algebra, and for the most part we are done with our question, right? So we're gonna have minus 5 being equals to minus 51 divided by 4 plus c. So you just take minus 51 divided by 4 to the other side. So if you do that, you can have minus 5 plus 51 divided by 4. That is 31 divided by 4, right? So now the equation of our line is y is equals to 3 divided by 4x plus 31 divided by 4, right? So let me just substitute x is equals to minus 17 and see if I get minus 5. So if I do that, let me see, yeah, I get minus 5. So I'm a bit convinced now that, yeah, we have the equation of our line PS.
Determine the numerical value of m. We are given n, the center of the circle, and that's where we have our variable m. Another information that we're given is the coordinates of r and s, together with the radius of our circle. It is said to be 17 units. So we can go ahead and try setting up an equation for our circle in the form x minus a squared plus y minus b squared being equals to r squared. So we're going to have x minus the x value of our center, which is 2. So we have x minus 2 squared plus y minus the y value at the center of our circle, that is m. We square that, and this is equals to the radius squared. The radius is 17 units, so we're going to have 17 units squared. As you can see, if we substitute a point on our circle, then we're going to easily find the value of m, because we're going to have a value of x and its corresponding y value. The only variable that we're going to have is m. So we can either substitute the coordinates of r or the coordinates of s and get the value of m. The coordinates of r, minus 13 and 5. If we go ahead and substitute that, we're going to have minus 13 minus 2 squared plus 5 minus m squared being equals to 17 squared. Minus 13 minus 2, that is minus 15 squared, plus 5 minus m squared. 5 times 5 is 25. 5 multiplied by minus m is minus 5m. You multiply that by 2, you get minus 10m. And then minus m multiplied by minus m, that is plus m squared. This is all equals to 17 squared. So we're going to have m squared minus 10m plus 25 plus minus 15 squared minus 17 squared being equals to 0. So we're going to have m squared minus 10m minus 39 being equals to 0. So we're factorizing this equation here. The question to ask ourselves, which two numbers do we multiply and get minus 39? But when we add them, we get minus 10. That is minus 13 and plus 3. So we're going to have m minus 13 multiplied by m plus 3 being equals to 0. M is equals to 13 or m is equals to minus 3. Let's look at m and its position and see what makes sense. M is the y coordinate. In the first, second, third, fourth, in the fourth quadrant, y is negative. So the answer we are going to take is that m is equals to minus 3. It is not equals to 13. Right, so that is the value of m. The question that follows, we're supposed to determine the equation of the circle in the form x minus a squared plus y minus b squared is equals to r squared. We have all we need to set up this equation. We're going to have x minus 2 squared plus y minus 3. So it is just y plus 3 squared being equals to r squared. We know that our radius is 17 units. So we're going to have 17 squared. What is 17 squared? That is 289. So instead of writing 17 squared, we can write 289. So let me just do that instead. We have 289. And this is the equation of our circle. Let's go to 4.1.2. Determine the gradients of NR. So let's go ahead and look at NR. We have the coordinates of R and we have the coordinates of N. So it will be pretty much straightforward. So NR will be equals to, let's say, y of R minus y of N divided by x of R minus x of N. So what is y of R? That is 5. And y of N is the value of m, which is minus 3. Everything divided by x of R, which is minus 13, minus x of N, which is 2. NR is equals to 8 divided by minus 15. And just like that, we have the gradient of NR. Let's go to the question that follows, B. We're supposed to find the gradient of NS. This is too good to be true. How can we find the gradient of NR? And then after doing that, we find in the gradient of NS. Something seems fishy, but we're going to find out soon. NS, do we have the coordinates of S? Yes, we do. Here they are. They're given to us in our problem statement. So we're going to have y of S minus y of N divided by x of S minus x of N. What is y of S? That is minus 11 minus y of N, which is minus 3. Everything divided by x of S. X of S is minus 13 minus x of N, which is 2. On the numerator, we have minus 8, and on the denominator, we have minus 15. So this is just equals to 8 divided by 15. We have the gradients of NR and that of NS. The question that follows, 4.1.3. The tangents at S and R intersect at P. Calculate the size of P2. 6 marks. So maybe we're calculating the gradients of NR and NS so that we can answer 4.1.3. Because without us calculating the gradients of NR and NS previously, 4.1.3 probably has a 9 or 10 marks. So it makes sense that we had to calculate the gradients of NR and NS so that we can use them to then find the size of angle P2. Let's see how we can actually do that. So P2 is this angle here. Let's just highlight it so that it is clear to see. We have the gradients of NS and that of NR. PS and PR are tangents, and the tangents are perpendicular to the radius. So if we have the gradients of NR and NS, we have the gradients of PS and PR. If we have the gradient of PR, we can find the inclination. Let's call that inclination K. So we have this angle here. Well, not of yet, but we know fully well that it is quite easy to find the size of that angle. And then we have the gradient of line PS. So it will also be easy to find the size of this angle, the inclination. Let's call it Q. But if the inclination of PR is K, then this angle right here should also be equals to K, a vertically opposite angle. So we can say that Q is equals to K plus P1. An exterior angle of a triangle is equals to the sum of the interior opposite. So if we find Q, which we have enough information to do, and we find K, then we can find P1. And if we find P1, we're going to use the sum of angles on a straight line to find P2. So let's start with K. Let's see how we can find the size of angle K. We know fully well that the gradient of NR, what is the gradient of NR again? It is minus 8 divided by 15. We want to use it to find the gradient of PR. So the gradient of PR multiplied by the gradient of NR should give you minus 1. Why are we saying that? The radius is always perpendicular to the tangent. So now we can say that the gradient of PR is equals to minus 1 divided by minus 8 divided by 15. This is just equals to minus 1 multiplied by 15 divided by minus 8. So the gradient of PR is 15 divided by 8. So let's go ahead and find the value of K, the inclination of PR. So we can say that tan K is equals to the gradient. So our angle K is equals to tan inverse of 15 divided by 8. And if you do that, you should get 61.93 degrees as the size of angle K. So now we have angle K. Let's go ahead and find the size of angle P. So the gradient of PS, will be equals to minus 1 divided by the gradient of NS. The gradient of NS is 8 divided by 15. So the gradient of PS will be minus 15 divided by 8. So Q, angle Q, will be equals to tan inverse of minus 15 divided by 8. This is minus 61.93. If we have a negative, we can just simply add 180 to find the angle of inclination. We're going to get 118.07 degrees. So now we have Q. Let's not forget, our point is so that we can say Q is equals to K plus P1. Q is 118.07. And what is the value of K? We just calculated it above. That is 61.93. So 61.93 plus P1. P1 should be equals to 118.07 minus 61.93. If you put that in your calculator, you're going to get 56.14 degrees. But then that's not it. We're not looking for P1. We're looking for P2. So P2 will be equals to 180 minus 56.14, and that is 123.86 degrees. Yeah, it is a long and painful exercise, but we have to do what we have to do. So that is 4.1.3. Let's go ahead and do 4.1.4. 4.1.4. Circle N is reflected about the x-axis and then translated 2 units upwards to obtain circle M. Determine the equation of circle M in the form x minus c squared plus y minus d squared is equals to r squared. Okay, we have a few translations here. Let's go ahead and look at the first one. So reflection about the x-axis. You just put a negative sign on the y value. So the coordinates of n were 2 and minus 3. If we reflect about the x-axis, we're going to get 2 and positive 3. because minus multiplied by minus 3 should be plus 3. So that is our reflection. And now we need our translation 2 units upwards. So 2 units upwards. How will that affect our equation? Now we have 2 and 3. We need to move 2 units upwards. From positive 3, if we move 2 units upwards, then we're going to have 2 and 5. If we moved 2 units upwards before the reflection about the x-axis, we were going to have 2 minus 1. But we're reflecting about the x-axis first before our translation. Hence, we have 2 and 5 as the coordinates of our center. Now, let's just conclude by setting up our equation. We have x minus 2 squared plus y minus 5 squared being equals to r squared. Nothing was said about the radius, so I'm assuming it's still the same, 289. 4.1.4. Let's move to 4.2. An infinite number of circles, each touching the next, are drawn between O and C. Let's just go ahead and highlight that. We have O at our center and C there. And then the centers of all the circles lie on the negative x-axis. The radius of the largest circle centered at A is 4 units. And the radius of each circle thereafter is halved. B is a point on the largest circle. 4.2.1 show that OC is equals to 16 units. We're supposed to show that OC is equals to 16 units. The first circle has a radius of 4 and a diameter of 8. And then the next circle will have a radius of 2 and a diameter of 4. And then we're going to have plus 2, plus 1, so on and so on until we reach infinity. So what I'm realizing here is that our first term is 8 and our ratio is 1 divided by 2 because the radiuses of our circle are getting halved. So if we have infinity circles between O and C, then we can simply say that the sum to infinity is equals to A divided by 1 minus R. A being the diameter of the first circle, that is 8. And we divide that by 1 minus the ratio. The radiuses are getting halved. So we have 1 divided by 2. And this is equals to 16. So indeed, the value of OC is 16 units. Let's move ahead and do 4.2.2. If BC is a tangent to circle A at B, write down the size of angle ABC, providing a reason for your answer. If BC, let's just join BC so that we can have a bit of clarity. So yeah, we need BC. Let's go ahead and just join those 2 points. BC is a tangent, AB is a radius. We know that the radius is perpendicular to the tangent. So that is to say that the size of angle ABC is 90 degrees because the tangent is perpendicular the radius. 4.2.3, hence determine tan of angle C. So we're looking for tan of this angle right here. Well, now we have a right angle triangle. This angle here is 90. So AC is our hypotenuse. Tan of theta is equals to the opposite divided by the adjacent. So the opposite is AB. So what is AB? AB is equals to 4 units. That is our radius. And what about AC? AC is equals to OC minus OA, right? OC is 16 units, OA is 4 units. So AC is equals to 12 units. AB is our opposite, AC is our hypotenuse. We need to find BC, our adjacent. Let's go ahead and do that and see what we're going to have. We can say that AC squared is equals to AB squared plus BC squared. AC, that will be 12 squared, being equals to AB 4 squared plus BC squared. So it should be easy to see that BC is equals to the square root of 144 minus 16. This is equals to 8 square root of 2. So now we can say that tan of angle C is equals to the opposite. The opposite is 4 units divided by the adjacent, which is 8 square root of 2. We can further simplify that, but let's just leave it like that. And 4.2.4, the last question, we're looking for the equation of BC. Angle C is the inclination of line BC. So this is the gradient of the line BC. So now we can say that y is equals to mx plus c, but we know the value of m. It is 4 divided by 8 square root of 2x plus c. We just need to substitute a point and we have the equation of BC. Which point can we substitute? We can substitute point C because we know that at C, the x coordinate is minus 16 and the y coordinate is 0. So if we substitute that, we're going to get 0 being equals to 4 divided by 8 square root of 2 multiplied by minus 16 plus c. So c will be equals to 4 square root of 2. And now we can conclude and say that the equation of BC, 4 divided by 8 square root of 2x plus 4 square root of 2.
4.1 says the equation of the circle centered at S, yes, S on the diagram, is x plus 8 squared plus y squared is equals to 4. 4.1.1, write down the coordinates of S, right? So 4.1.1. We know that the general formula for the equation of a circle is given as x minus a squared plus y minus b squared is equals to r squared. And then the point at the center of the circle will be given by a and b. So for our circle centered at S, the coordinates of S will be given by minus 8 and 0. It just says y squared, right? So that will just give us 0. And then this 8 will give us minus 8 based on this general formula we have, right? And then let's do 4.1.2. 4.1.2 says, show that the diameter of the circle centered at S is 4 units. So what is the diameter by definition? The diameter is equals to 2 multiplied by the radius, right? But what is the radius of our circle? We know that from the general formula, x minus a squared plus y minus b squared shall be equals to r squared. And we're given r squared. So with r squared, we can find r and ultimately find the diameter, right? So r squared is equals to 4. Here it is right here, right? So we say in r will be equals to 2. We take square roots on both sides, right? So d, the diameter, will be equals to 2 multiplied by r, which is 2, and this is all equals to 4. So the diameter is equals to 4 units, and that's exactly what we are asked to show. Now let's move to 4.2. 4.2 says that if it is further given that SR is equals to 8 units, right? So SR is equals to 8 units. Problem solving 101. You have to write down the given information, right? And then R has coordinates minus 8 divided by 5 and 24 divided by 5. Yes, R here. And then 4.2.1 says, let's find the length of EM. So let's denote EM on our sketch. So here's EM. The radius of our big circle, right? So what information do we have? We know that SR is equals to 8 units. We also know that the radius of the small circle is 2 units, right? So we can say SE is equals to 2 units, right? SE is this distance here. We're saying it's 2 units. and then SR, this entire distance is 8 units. So we can basically find the length of ER, right? And ER will be the diameter, which is 2 multiplied by the radius, and EM is our radius, right? What am I saying? I'm saying that SR, right, and the entire distance from S to R will be equals to SE, the radius of the small circle, plus ER, right? But then you can see that ER is the diameter, right? So it will be equals to 2 multiplied by the radius of the small circle, which is 2 multiplied by EM, what we are asked to find. So in place of SR, we can put 8 units. In place of SC, that's 2 units. And then in place of ER, that's 2 multiplied by EM. So you can see now that EM will be equals to 8 minus 2 divided by 2, right? So 8 minus 2, that is 6, and then 6 divided by 2, that is 3. So EM is 3 units, right? And now we can do 4.2.2. 4.2.2 says, let's find the gradient of tangent FE, right? FE is the tangent of both our small circle and our big circle, right? So we know fully well that the radius and the tangent are perpendicular to each other, right? The product of their gradients will give you -1. So if we find the gradient of ER or the gradient of SE, then we're going to be able to find the gradient of tangent FE, right? So let's find the gradient of SE since we have coordinates S, right? But wait a minute, we don't have the coordinates of E. So how are we still going to find the gradient of SE? The gradient of SE will also be equals to the gradient of SR because it is one straight line from S to E to M to R, right? So the gradient on that line is the same. So we can just use SR to find the gradient of SE. So that will be equals to y2 minus y1 divided by x2 minus x1 by definition. So let's take R as our second coordinate, right? We have the coordinates of R here. So y2 will be 24 divided by 5, and then y1 will be 0, right? Because S rests on the x-axis. So 0 divided by x2 minus 8 divided by 5 minus x1 of S, right? We know that that is supposed to be minus 8, so it will be basically plus 8, right? And then when you compute that, you get 3 divided by 4, right? But we know that m of SE multiplied by the gradient of the tangent should give you -1 by definition. So the gradient of the tangent will be equals to -1 divided by 3 divided by 4. So that will be equals to -1 multiplied by 4 divided by 3, that is -4 divided by 3. So the gradient of the tangent is -4 divided by 3. And now we can do 4.2.3. 4.2.3 says, let's find the coordinates of M. The coordinates of M. So M is the center of the big circle, right? What do we know up to this point? What do we know about up to this point? We know the radius of the big circle is 3 units, right? And then we know the radius of the small circle, it is 2 units. And then we know the coordinates of S, and then we know the coordinates of R. That's all we know, right? And we sort of know the X value, the Y value of our coordinate P, right? So we have to find the coordinates of M using this information that we have. So how can we possibly do that? So M and P, they share the same X value, right? That is because if the x-axis touches the circle, then where it touches the circle will be the x value of the center of the circle. And then if it touches it along the y with the y-axis, then the y value will be the y of the circle, right? So M and P, they share the same x value. So if we can find the x value of P, we have the x value of M, right? Now we can see that SM squared is equals to SP squared plus MP squared. So what is SM? SM is SE plus EM, right? So that is 2 plus 3. So we have 5 squared being equals to SP. We don't have SP, but that's what we're looking for, right? So that we can find the x value of P, right? And then plus MP squared. MP squared is EM squared because they're all radiuses, right? From M to E, that's the radius. From M to P, that's the radius. So we have the radius is 3, so we have 3 squared, right? So SP squared is basically 5 squared minus 3 squared, right? So SP will be equals to 5 squared, that's 25. 3 squared is 9. So 25 minus 9 is 16. Square root of 16 is 4, right? So SP is equals to 4. But we know that the coordinates of S is minus 8 and 0, right? And then we have P, which is the x value, and 0 here, right? But we know that from S to P is 4 units, right? So what can be the possible value, x value of P here? It should be clear that the only possible value of P such that SP is equals to 4 should be minus 4, right? The descent from S to P will be 4 if the x value of P is 4. So now we have found the x value of our coordinate M. It's minus 4 and some y, which we do not know. Let's go back to our sketch again. If you pay more attention, you will realize that from P to M is 3 units, right? Because that is the radius, is 3 units. We already know fully well that the y value of P is 0, right? So if from P to M is 3 units, then the y coordinate of M should be 3. So the coordinates of M will be minus 4 and 3. Right? And now we can move to 4.3.4. So we have 4.3.4, which says we should find the coordinates of E. So let's just erase some of this stuff. So here's E here, and we are interested in the coordinates of E. Now we have the coordinates of M, and we have the coordinates of R. It should be obvious now that we're going to use the midpoint theorem, right? We're gonna use M as a bait basically to find the coordinates of E, because we know that x of M, since it is the midpoint of ER, right? Why are we saying it's the midpoint of ER? Because from E to M is the same distance as M to R, and they're on the same straight line. So M is the midpoint of ER. So we can say x of M is x of E plus x of R divided by 2. But we know x of M fully well. That is minus 4, right? So we have minus 4 being x of E plus x of R. X of R is minus 8 divided by 5, right? And then everything divided by 2. You cross multiply, you get minus 8 is equals to x of E minus 8 divided by 5. So minus 8 plus 8 divided by 5 is equals to x of E. And then if you put that on your machine, you will get an x of E, which is equals to minus 32 divided by 5. So we have x of E being equals to minus 32 divided by 5. Now we can move our attention to y of E. We are applying the same idea. We say that y of M will be equals to y of E plus y of R divided by 2. Y of M, that is 3, right? We have already established that then y of e plus y of r, which is 24 divided by 5, everything divided by 2. And then now we can cross multiply. You get 6 is equals to y of e plus 24 divided by 5, right? So we have 6 minus 24 divided by 5 is equals to y of e, right? So what is y of e? Y of e will be, if you compute that, you get 6 divided by 5, which makes total sense, right? It's just slightly above 1 because 6 minus 24 divided by 5 should be 1 point something. So now we have e having coordinates minus 32 divided by 5 and 6 divided by 5. And there we go. Let's do 4.3. 4.3 says the circle centered at M, right? Circle centered at M. So we have M being minus 4 and 3. And then now on 4.3, they've given you the coordinates of M. Yeah. So it's shifted 1 unit to the left. So let's shift M 1 unit to the left, right? So it was at minus 4, which shifted 1 unit to the left, it will be at minus 5, right? And reflected on the x-axis to form a new circle centered at K. So it is reflected in the x-axis. So when we reflect in the x-axis, let's say we had a point A, right, of coordinates x and y. When you reflect on the x-axis, you get a, x, and then minus y. So when you reflect on the x-axis, you just have to put minus on the y value. So we have minus 3 here, right? Let's erase this. So there we go. We have our new center of the circle, right? The question is asking us, determine whether the point minus 8 and 0 lies inside or outside the circle centered at K. Show all calculations. So we've shifted the circle, right? We haven't changed the radius and everything. So the radius of our circle is still equals to 3, right? So when we calculate, let's name this point L. When we calculate the distance of ML, right? M is our new center, right? If it is greater than 3, then it makes sense to conclude that the point L of minus 8 and 0 lies outside of the circle because the radius of our circle is 3. And then if it is less than 3, then that point will lie inside the circle. And then if it is exactly 3, then it lies on the circumference of the circle. So let's go ahead and compute ML. So we're saying that ML will be equals to, we know the distance formula, y2 minus y1 squared plus x2 minus x1 squared. So let's just go ahead and sub it in. So we're gonna get y2, let's take L as our second point, so that will be 0 minus 3, so that will be plus 3 squared, plus minus 8 minus 5, so that will be plus 5 squared, right? So we basically have 3 squared, which is 9, and then minus 8 plus 5, that is minus 3. So we have 9 plus 9. So we have the square root of 18 is the same as 3 multiplied by the square root of 2. So 3 multiplied by the square root of 2 is definitely greater than 3, right? So that point lies outside of the circle. So the point is outside the circle.